Hi, I'm Doug Bakewell, the creator of the Python programming game Netbots. In this video, we're going to try and talk about really how to write a better bot and how to defeat the demo bots, but then also how to make the best bot that you can. This is primarily going to be a concepts video. I'm not going to get into the details of the code too much. I'm going to assume that you've read the manual. If we go back to the Netbots GitHub page, you can read all of that. That's got all the descriptions, the manual, it explains it. It tells you how to run the demo, how to start writing a robot, the very, very basics. So I'm going to assume you've done all that. You've done a little bit of a read through this. You've played with the code, maybe run a tournament, which is important as well, just so you can test faster. So I'll assume all that. What we really want to concentrate on is the how to write a better bot. And I want to talk about a few of the primary challenges to doing that. The first one is simply that this is Python. I know that a lot of people working on netbots are coming from maybe a Java or a C background. So I won't go into Python except to say, obviously you can Google it. The GitHub page for netbots has some resources for Python. Definitely spend some time on that if you're frustrated with Python. Yeah, it's a great language, so learn it. Now, NetBots itself, it's an environment you may not have worked in much before, depending on what your background is. The first thing to know about NetBots is it has very limited information. So when we talk about writing a better bot, we need to consider information management, and I'll talk about that constantly as we go through. Now, part of that information management concerns points 2 and 3 here. The first one is the idea of an unreliable network. So you need to think about this in that, let me just flip it and maybe do a little doodle for this one. If you have the NetBot server and you have your bot and they're communicating, so there's a server, and your bot sends a message, that message may not get through. Your bot may have to resend that message before it gets a reply. So that's something to keep in mind. The other thing to keep in mind is that your bot might send a message and the reply might never come back. And then your bot might resend that message and then you might get another reply back for it. So an example here is you might ask the server to fire the cannon, but you might never get a response back. So you would ask for it to fire the cannon again, and then you would get the response back saying it's correct. I'm not going to go too deeply into that. I'll touch on a little bit. Just know that it is an important concept, an unreliable network, and I'll touch on it over and over as we go through. The last one that limits your information is the idea of a real-time system. So everything is moving. So if we go look at a picture of the interface here, and we have a few robots running around, if we did a get info request and we know where we are, but let's say we're a robot and we're moving this direction, then that get info is old as soon as we get it, because we got it one step and then we've actually moved forward a little bit for the next step. The same is true for everybody else. So if we did a scan and we found this robot out here, so we know that that's the distance to the nearest robot, distance D, but we're moving this direction and this robot's moving this direction, it might change, or even worse, if we're both moving at each other, let's say. So in the case of if I'm moving this direction, he's moving at me as well, the distance that I compute with a scan is going to be quite different over time. So everything's constantly changing, everything's constantly in motion. So given these challenges, how do we write a robot? And I have a few different points here. The first one is to build on what you have. So I would say start with the demo robots. I'll just flip to that for a second. If you haven't looked at it yet, I'm assuming everyone has at least a little bit. In the netbots root, there's a robots directory. In there are several robots that demonstrate how to move, compute an angle, how to scan and fire, how to avoid things. That sitting duck just sits still, does nothing, and how to run at max speed, detect when you've stopped. There's lots of things there. I won't touch on team robots right now. We'll leave that for later. So definitely look at those demo bots And what I suggest you do, and I'll give an example of this later, is you start with one of those demo robots and you get it to defeat all the other demo robots. And then you keep that robot and you copy it, and then you make another robot better than that that can defeat that bot. Once you've done that 3 times, you don't even need the demo robots anymore. You're purely have your previous robots to try and create games against and try to improve on. So that's the most important thing there. And as you do that, there's another very important thing that I think gets missed a lot, is to use the stats. So if we just flip to an example of the scoreboard, so if I go back to the root of Netbots, there's several things that come out, and the scoreboard's not all of it. If you look at the output from both the server and your robot, you're going to see a lot of statistics on network, what types of network packets have been sent, what types of messages have been sent back and forth. And we'll talk about that later as well, because that's important. But just off the scoreboard, there's very important numbers here. So when a robot shoots, what's the average amount of damage that it inflicts? That's not always the most important thing to winning. You'll see here that, the robot that has won actually inflicted less damage per shot, but it is a factor. How well did you aim? The other factors, though, are things like how often did you shoot? So here's a robot who shot 29,000 times versus one that shot 21,000. So if you look at their relative amount of damage they did, even though the winning robot maybe did less damage per shot, he shot more often. So those are the sorts of things you can look at. The other thing is the average amount of health when you won. That tells you kind of the spread. There's the point spread as well, but there's also the spread on average health. While we're here, we'll talk about a couple other things in case you're having real problems. Definitely watch a couple numbers here. This one especially, as you start to speed up the server, if you start to have a lot of slow steps, more than say 1 or 2%, you probably need to slow the server down. Your hardware is probably not quite fast enough to handle it. Let me just see if there's anything else here that you might want to keep an eye on. Messages dropped. I mean, again, we talked about messages, but you can turn that off. There's a server switch to turn off messages drop to see if that helps your robot. Sometimes your robot is a great idea, but it's just not working, and it's not working because of the message drop. So maybe try turning off message drops for your server and see if your robot works better. And if it does, then think about how you can make it work with the unreliable network, because the turning off message drop makes the network look completely reliable. Okay, so again, that's statistics. There's also network statistics that I suggest you look at. How many get info requests you're making, how many times you're asking the cannon to fire, those sorts of things. All very important to analyze when you're comparing your bots, trying to make them incrementally better, one on top of the other. Okay, so that's kind of the basic stuff. Let's get into the more interesting. There's kind of 3 big areas, and I'll just zoom out so you can see all. So the first one is, as far as what you can do, is you can try to reduce the damage to your bot. Obviously, if your bot takes less damage, you have a better chance of winning. You also have to try to inflict damage on other bots. If you don't do anything to try to defeat other bots, then there's no way you could possibly win. And actually finding a balance between those two is a key to writing a good robot. And the last one, we've talked a lot about managing information at the start, and I'll talk about it again at the end. But let's dig in, first of all, to reduce damage for your bot. So the first one is avoid hitting walls. The second one is avoid other robots. So let's just talk about that for a second. So let's talk about hitting walls first. To start with, if you hit a wall at full speed at a 90-degree angle, okay, so this angle right here is 90 degrees, you're going to take more damage than if you were to hit it at full speed at less of an angle. So know that if you're going to hit a wall and you skim it, that's far better than hitting it head on. So you can try kind of manage that and think about that. When it comes to hitting other bots, you have to know where they are. So if you're moving in a particular direction and you never scan in that direction, you'll never know there's somebody that you might hit. Now, I'll be honest, the robots I work with, I rarely worry too much about hitting other robots. I don't think it's a great strategy, but I've seen other people actually use that to their advantage. They kind of know where the other robots are and they actually stay away. Because if you know that, well, this area of the map doesn't have anyone in it, so you progress to go there, that's not a bad idea. And that will avoid hitting other robots. Oops, let me go back to my proper page here. So the other two things to avoid damage is really to avoid being shot. And there's two things. Keep moving and keep turning. Now turning might be one you haven't thought about yet, but we'll get into that in a minute. So if you think about keep moving quickly, so again, if this robot, say, is moving this direction and this guy scans where he is, that's not a very good scan. And he scans where he is, so he finds out, that distance and that angle, then he's going to fire a shot. So he fires a shot there. She draws a little arrow. So dupe, dupe. But this guy's also moving at the same time. Dupe. This guy's there. That gets there. It blows up. This guy's already over there. So as this guy's progressing this direction, the faster he's moving, the more likely the shot is going to not hit. And the other one is turning. Sorry, let me go back to this as well. So some robots, and this is more, we'll get into this a little bit later on, if you're moving this direction, this robot might know that. So he might actually shoot the direction that where he knows you're heading. In this case, turning while moving is a strategy as well. It's a much harder one to implement. And remember, the sharper you want to turn, the slower you need to go. The faster you go, the harder it is to turn. So you have to balance turning with speed. Certainly the simple strategy I would say is worry about speed first and worrying about turning as an avoidance mechanism second. Okay. So that's kind of the main ways to reduce damage. And I will say it is possible to shoot yourself, so you can actually fire and damage yourself, especially if you're driving into your firing. So keep that in mind if you're shooting at someone very close to you. Okay, inflict damage on other bots. So this is by far the bigger topic, though, is how do you shoot other people effectively and use your cannon as best you can? So the first thing that I want to remind everyone is really read the documentation on scanning. I'm just going to scroll down to the scan example here. So this is an example of a scan. So you need to understand what the scan is telling you. What you're inputting is the start scan, so that's the pi, and your end scan. So in this case, it's 1.2 pi. And you're getting back a distance. It doesn't tell you that this robot's here, okay? That's not what it's telling you. All that it's telling you is somewhere on this line, there was a robot when the scan was done. Again, everything's in motion, so it takes a step to do the scan, a step for the message to come back. So it tells you that when the scan was done, somewhere on that line there was a robot, but you don't know where. He could have been here. He could have been here. You don't know that. So understand that and get a good concept. Also know that if there's two robots, one far away and one close, it's going to return the closer one. So sometimes you'll do a scan and then you'll do another scan and all of a sudden it'll change drastically. And maybe this robot drives out of the scan and this guy's heading this direction. And you think that, oh, there was a robot here, now there's a robot here. And you think it's the same robot, but it could be a different one. So understand the scan is very limited. And it's designed that way. It's a very limited information. The more you scan, the more information you have about the world. So again, read the docs about that. Make sure you understand that. An obvious one that some people miss is don't fire while you have a shell in progress. So if we go look at, if we go back and look at an example here, I think there's one of these guys that's got a shell in the air somewhere. Yeah, so the yellow robot here has fired this little yellow shell right here. So he's about to hit this red robot, which is fantastic. But if he were to right now fire again, this shell would never blow up. And he can do that. So there's the call you can make, shell in progress, which is a message to ask if your shell's still in the air. We'll talk about how that maybe is a good idea, maybe not a good idea in just a little bit. But definitely know that if you fire, you're just and you have a shell in there, you're just wasting the first shell. Sometimes that might make sense. Sometimes maybe you made a shot that was really far away. It was a really risky shot. You don't know if it's going to hit anything. And then you find someone very close. Maybe it makes sense to fire on the close person and just ignore the other shell. The next one I'll talk about is locking on target. And this is kind of the first major thing if you haven't thought about it yet. And we'll actually go look at the Lighthouse code to do this. But before we do that, let's just talk about what Lighthouse does normally. So Lighthouse's normal strategy, and actually Lighthouse is the red one, so we'll use him. So this guy right here, he will scan. You can see his tiny little scan radius. So he has a very little scan radius. So he's scanning like this, and he's looking, and and what he does is he just scans, and then he scans this way, and he scans that way, and he's just scanning in a circle. So he's just slowly scanning, doop, 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 doop. He's looking around. And then when he finds something, so if he finds this guy, he fires on him. Doop, 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 doop. So he fires a shell. And then the next time he goes to scan, he just keeps, like a lighthouse, he keeps looking. He's not going to find him. He has to go all the way around again. And then he finds him again, and then he fires. So it's a little silly. So the first thing that Lighthouse could do to be better is to lock on. So he could go, I fired, my shell blew up. I'm going to see if the thing I just shot at's still there. Hey, it is. I'm going to fire on it again. And you might think, oh, that's a whole bunch of code. It's hard. It's actually, in the case of Lighthouse, very easy, and it's a very powerful change. So I'm just going to go there now. So we're going to go to robots. I'm just going to look in Lighthouse. So if I look at the code of Lighthouse, I'm not going to dig in deep. I'm just going to do this very quickly. You can dig in yourself. But if we look at this code right here, let me see if I can get this to zoom. There we go. Okay. So I'm just going to briefly talk about what this is doing. What we're seeing here is that if the scan returned a robot, we're going to fire it down the middle of the scan, and we're going to send that fire cannon request. And then we're going to change our mode to wait. But the other thing that we're doing is we are immediately going to the next scan slice. So we're moving forward. The lighthouse is continuing to rotate. So try this as a change. And it's very, very simple. You just do an else, and you indent that line. So what this is saying is, if I found someone in my scan slice, I fire on them. If I didn't find someone, I continue, like Lighthouse, to rotate around. So what this means is the next time I go to scan, I'll scan the same slice, and I'll keep scanning it, and I'll keep firing down that slice until there's nothing in that slice anymore to fire at. So try that simple change. Okay, so that's lock on target. Now, again, that is just the Lighthouse example. Depending on your robot's implementation, there's all sorts of ways to lock on, and actually we'll talk about even making that more advanced in kind of 7 and 8 here. Next one is pick your scan width wisely. So let's talk about that one. So if I wanted to scan a robot that was very far away, and I want to hit him, because you have to remember my explosion is only, say, this big, and I'm probably going to fire down the middle of my scan. That's probably a smart thing to do. So I'm going to shoot here. He's going to be inside my explosion. Now, if my scan radius was rather ridiculously big, say like this, and then I find him, so I find that distance, and I shoot down the middle, and I have my explosion, I'm not going to hit him. That's because my scan width was so large, I didn't really know where he was. I knew the distance, but I had no idea what the angle was. But this isn't completely useless. If I found that I use this width and I found a robot right here, actually I'll make him a little more off angle. Let's say I found one and he was right here. Then if I fired up the middle and I had an explosion, I would actually hit him. Because he's so close, the distance of the scan isn't so wide, but the further the scan is away, the larger it fans out. So if you take the example of Lighthouse, he's always using, and you can see it on the display, this is the width of his last scan. He's always using a very small scan. Now, if you look at this robot up here, he's actually scanning half of the environment. He's doing a huge scan. And that's just to tell him, maybe he's doing a binary search. We'll talk about that in a minute. But it's telling him what's below him, what's the closest robot below him. So this is not useful for scanning at all, really at any distance, where Lighthouse is very useful for scanning even at a very distant object. But what's the right mix? Because, of course, Lighthouse has to do a lot of scans with its small scan to find a robot, where, this simply tells you, is there any robot below me in the case of the blue robot here. So think about scan width, and you can change that scan width, whether you want to shoot something far away or if something's close. You might want to do more scans if something's far away to narrow down that angle. So think about that one. And that's really what, that's what I just talked about, was variable scan width. So you might want to start with a wide scan and say, if I found something and it's close, I'm just going to fire at it. If it's not close, I'm going to sub-scan. I'm going to scan the sections of that first scan at a smaller angle each and find out which of those is in, which one contains the robot before I shoot at it. And you can do that iteratively several times. And that kind of brings us down to the idea of binary search. So if we talk about those few things we just spoke about, let's talk about how we might use a binary search algorithm. So I'm assuming you are vaguely aware of, say, doing binary search on an array. So if you want to search this array, and you assume that this array is sorted and it has some numbers in it like 16, I guess I'll have 19, 32, 81, 99. And I'll just make this very easy on myself, 102. And you wanted to search this, you could start dividing things in half. So you could, actually, I'll get rid of the 102. So you could look at the middle number first and go 32, and I know this is sorted. So, and let's say I'm looking for the number 9, or let's say I'm looking for the number 16. And I go, well, I know it's on the left side because I know that the right side's higher. So now I don't need to search any of this. I don't have to go through. I know it's over here somewhere. So then I can look at this and I can say, well, now I know it's one of these two, blah, blah, blah. That's a very simple description of binary search. But what's binary search in this context? So if we take a robot, and we'll start with the blue one here, and we think about what he's trying to do. So let's imagine he's doing binary search, and I'm going to use 0 radians being to the right. So again, this is the way Netbots is set up. So remember, 0 radians is to the right, pi is to the left, and I'll speak in radians. So I might do a scan this way first to say, where's the closest robot? So this is going to return nothing because there's no robot above me. And then I'm going to do a scan at the bottom. And this is then going to return really this distance, because that's the closest robot right there. So now I know that that the bottom is better. So now I've reduced it by half. So with just 2 scans, I know whether I want to shoot above or below myself. If you think about Lighthouse, Lighthouse is constantly scanning around. He might do 15 or 20 scans before he even knows whether he wants to shoot above or below himself. If blue was Lighthouse, he might do 1, 2, 3, 4, 5, 6, 7, 8. And he might do a whole pile and get absolutely nowhere. So here, with just 2 scans, I know that I want to go below myself. So now I can say, well, this is a binary search. So binary search is always dividing the search space in half. So the search space started as the full circle. Now I've divided it down to the bottom half of the circle. So now I can take the bottom half of the circle and divide that into 2 pieces. So there's my first scan, and there's my second scan. So my first scan is going to return the same guy I had before, and my second scan is going to return this guy. So I know that the distance to the first one, that's D1, is closer than the distance of D2. So now I can make a choice. So now I've identified 2 of these that have someone in it. Now, I might want to shoot at the guy who's closer and ignore the guy who's further, because it's easier to shoot at people that are closer. It takes less time, it's more accurate. So I'm going to ignore this. I'm going to say, you know what, I'm going to get that. So now with just 1, 2, 3, 4 scans, I've got myself down to a quarter of the circle. And now I can do it again. So this time I can scan that as my first scan, and that is my second scan, and the first scan is going to return nothing because there's no one in that segment, and this one's going to return this distance. And then I can do that again. So I can then go and scan the first scan and then the second scan. This now tells me that the second scan has nothing in it. And now I've got this. And now I might look at this and say, okay, this is a fairly small scan slice. Maybe I want to shoot now. And I'm going to shoot right there. That's my angle and distance. And there's my explosion, and I'm probably going to hit him. So where Lighthouse, starting from 0, might have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 or so scans. What I did was 1 scan, 2 scans, 3 scans, 4 scans, 5 scans, 6 scans, and I was ready to fire. So that's a simple binary search algorithm in a circular space, and it really reduces down the amount of time that you might take. So using binary search, now there's other algorithms you can use as well. Binary search is just one of them, but it's a smarter algorithm than just Lighthouse. Lighthouse of just scanning around in circles is very slow. So the faster you find something to shoot at, the more damage you're going to inflict. If you consider that as being part of that variable width and being careful about at what point you shoot, based on distance and other things, you can start combining these things. And then if you get your binary search to lock on, in other words, not start over at the beginning when it fires, but start opening up, because you can have your binary search close down and open up. If you don't understand that concept, let me do it right now. So let's say I fired down this slice and it exploded, but during that time, this guy's moved over here. So then I've tried to lock on by using the same slice, but he's not there anymore. So now I don't find him. I don't have to necessarily go back and start scanning all over again by scanning top and bottom. You can, and that works actually quite well. But what I can do is I can say, open the scan up again and see if I can find out where he's moved to. So that's another option. So that's locking on kind of reverse binary search. Again, much more powerful. And then there's 2 other things that we haven't talked about. The first one is, again, everything being in motion. So I might be traveling this direction and this robot might be traveling this direction. So when I scan, I want to shoot him like that. But when I take this dotted line, if I'm here now and he's there, when I fire, so I'm actually going to fire at the same angle and distance. Well, the same angle and distance is this. That would be my explosion. Because I've traveled and he's traveled, I'm going to miss him. So just firing based on angle and distance is one approach. But the other approach is to go, okay, so this guy, I know, well, I don't know, I've scanned. I know that somewhere's on that arc, so I'm going to assume he's right there. So I'm going to assume that's where he is, and I know this as an angle and distance, but I can use trigonometry based on my position, so I know my x, y, or maybe I do, maybe I don't. I know the angle, right? So I mean that would be the reverse angle. Let me draw this better. So I know the angle on that, and I know the distance. So I know the AY, and I probably know my XY. So using a little bit of trigonometry from math class, you can figure out the XY of this. So then when you go to shoot at it, okay, because we think that, I've moved. So now I'm here. I don't want to shoot on the angle and distance. I want to shoot at the XY that I know where he is. So if I'm here, I want to shoot here. So I can compute a new angle and new distance based on where I am. So that, again, is much more sophisticated. Now, whether you're using any of the other search techniques or anything, you can still do that. Finally, you can combine the last powerful thing here. And I mean, I shouldn't say last. There's probably lots of things you can do. But if I'm using some sort of lock-on mechanism, and I know that I thought he was there, and I shot at that point. So I thought he was at XY. And then I do my scans again, and I find another robot here, which I think is the same robot. So this is X prime, Y prime. So if I think this is the same robot, and I shot at him at XY before, and now I think he's at X prime, Y prime, I should not shoot at X prime, Y prime. I should shoot here. So this is where I think he's going. So I can actually shoot at X double prime, Y double prime, which is something I can compute because I know I can take a linear line between these points and I can just extend it. Again, a little tricky, a little bit of math for that, but that's another thing you can do. So you think about this, make sure you understand what the scan's doing, what it's telling you and not telling you. Locking on your target, picking your scan width wisely, shooting with the right width so you have the right amount of accuracy at the distance, using binary search. And then if you really want to get advanced, you can start looking at the XY you're shooting at rather than the angle distance and actually anticipate where the enemy robot's going to be. Okay. Wow. So that was a lot. That was inflict damage. So let's talk about the last little bit here, which is manage information. So I've talked about a lot of things that require a lot of scanning, especially a lot of scanning, a lot of info requests potentially that you're doing. But what you need to start saying is I need to prioritize the information that's most important to my algorithm. So if you're a robot that's more defensive than you are aggressive, then maybe you care more about those info messages. You care about accurately knowing where you are. To me, scanning is always important because if you're defensive, you want to know where other robots are. If you're aggressive, you still want to know where other robots are. So scan messages, the more you can scan, the better. Again, if you look at the stats, look at how often your robot's scanning, look at how often it's doing get info requests. Look at how often it's doing shell in progress requests. Shell in progress especially is an interesting one. I never use it on my more advanced robots because when I fire, so if I fire my cannon, I know at what time I did that. And you can count time and all sorts of things. You can count it in using the clock. You can count it with the number of messages you've sent, how many times through your loop. But I know what time I fired, and I know the distance. And I know shell speed from the conf message that comes back. The server will tell you the shell speed. So I know how long that shell should be in the air. So I should never have to use the shell in progress message because I should be able to fire and know how long I have to wait. So again, if I don't have to call shell in progress, that's another scan I can do. Because you can only do one. If you're using the send receive message that's synchronous, you only get to do one of those per step at most. So you're wasting them if you're using shell in progress. The same is kind of true of get info. If you know that you're heading towards a wall, so let's say this guy's heading towards this wall, you know your speed because you've requested it, and you know the distance. So you should know how long before you have to check where you are. Now, it's true, a robot might come and hit you, and that would cause you to stop, which is bad. But you have to balance that risk with the idea of calling get info versus being able to scan again or fire your cannon or something else that you want to do. So very important that you think about that. The more you're getting those info messages, the more you're wasting scan. And the demo robots are terrible for this. Their basic design is fairly inefficient. There's lots you can do to make them more efficient. Again, this is guess. Sometimes you can use a clock that's not very good, number of times through your loop or something. Just guess. It will be good enough. This is a system with limited information. Guessing and doing scans or firing your cannon or turning or managing your turns often is more important than knowing exactly where you are. or knowing whether your shell is in progress if you have another way to determine that. And the final one about managing information is to change your behavior based on what you know. So this is a tricky one. Once you've written a whole pile of robots, you may have written some that are very different. You might find some work in some situations, other work in other situations. If you can detect the situation, you could combine those two robots into one. So you could have it see a certain situation and behave a certain way, and then behave a different way at a different situation. A good example of that is if you detect that there's a lot of robots still alive, maybe you hide. Maybe if you detect there's maybe only one robot alive, you become more aggressive and actually go after that robot. So that's the kind of thing. That may not be a great example. There's better examples. I'm not a big fan of hiding, actually. I find that being not fully aggressive, but not fully defensive, finding a balance is quite good, but definitely changing behavior over time. Okay, so that's the concepts I wanted to talk about today. If you have questions, feel free to post a message on GitHub. You can do that by going to Netbots and going and creating an issue. And when you create a new issue, you can just ask robot programming help, and you can ask a question that way down here at the bottom. And I'm happy to answer questions as I have time. All right, thanks for watching the video. I hope you enjoyed it, and enjoy Netbots.